Friends, welcome to the class. Today we'll discuss about areas related to circles. Friends, already we had a discussion on circles, tangents, chord. In this class we'll have a small recap that we discussed earlier, and then we'll start the other areas of the circles. So let's start. Circles. A circle is a locus of a point which moves in a plane in such a way that its distance from a fixed point remains same. The fixed point is called center of the circle, and the constant distance is known as radius of the circle. The radius of the circle is denoted by small r. Chord. A line segment joining any two points on the circumference of the circle is called a chord of the circle. Diameter. The chord passing through the center of the circle is called the diameter of the circle. The diameter of the circle is twice of its radius. That means diameter equals to 2 into radius, or it is written as 2r. Semicircle. A diameter of a circle divides it into two equal parts or in two equal arcs. Each of these two arcs are called semicircles. Circumference. The length of the complete circle is called circumference of the circle. Arc. A continuous piece of a circle between 2 points is called an arc. Central angle. An angle subtended by an arc at the center of a circle is called its central angle. Quadrant. 1/4 part of a circle is called quadrant of the circle. In the given picture, AOB is the quadrant of the circle. The central angle of the quadrant is 90 degree. Because quadrant is, as it is said, it is 1/4 of the circle. This complete angle is 360 degree. As this AOB is the quadrant, it is 1/4. 1/4 of 360 is nothing but 90 degree. Second, a line which intersects a circle at any 2 points of a circle is called secant of the circle. In the given picture, PQ is the secant of the circle. Friends, there is a minute difference between a chord and a secant. If we eliminate this PX and QY, we can say XY is a chord, but PQ is a secant. It means chord is a line segment which connect any two arbitrary point of a circle. A chord always lie within the circle, whereas a secant, it intersects the circle at 2 points, and the end points of the secant lies outside the circle. This is the basic difference between chord and a secant. Perimeter of a circle. The length of the boundary of a circle is called perimeter of the circle. It is equivalent to the distance covered by the circle in one complete rotation. Perimeter is also known as circumference of the circle. The ratio of the circumference and diameter of the circle is always constant, and this constant is denoted by pi. The value of pi is equal to 3.1416 or 22/7. So circumference by diameter equals to pi, or we can say circumference into pi into 2r. 2r is diameter, or it is nothing but 2 pi r. Area of a circle. The area of a circle with radius r is given by pi r square. Area of a ring. Ring means two concentric circle. If capital R and small r are the radii of a ring, then the area of the ring is given by pi into capital R square minus small r square. And that means pi into capital R square is the area of the larger circle, and pi into small r square is the area of the smaller circle. So area of the larger circle minus area of the smaller circle gives the area of the ring, or we can say a circular path. Some important formulae. The first one, circumference of a semicircle equals to pi r plus 2r. Circumference of a quadrant of a circle is pi r by 2 plus 2r. Distance covered by a wheel in one rotation equals to circumference of the wheel. Number of rotation a wheel make in traveling a certain distance equals to total distance traveled by the wheel by circumference of the wheel. Area of the semicircle equals to pi r square by 2. Area of the quadrant is pi r square by 4. Let's see some examples. The diameter of a cycle wheel is 21 cm. How many revolutions will it make to travel 1.98 km? So given that the diameter of the cycle is 21 cm, that means 2r equals to 21 cm, and the distance is 1.98 km, or we can write it as 1,98,000 centimeter. Now, the distance traveled by one revolution equals to circumference of the wheel. That this implies distance traveled by one revolution equals to 2 pi r, or pi into 2r, or in this case it is 22 by 7 into 21, which is 66 centimeter. That means in one rotation the wheel of the cycle moves a distance of 66 centimeter. So number of rotations a wheel in traveling distance equals to total distance traveled by the wheel by circumference of the wheel. So in this case the total distance is 1,98,000 km. Sorry, 98,000 centimeter. So number of rotation made by the wheel is 1,98,000 by 66, which is nothing but 3,000. Hence the number of revolution is 3,000 is the answer. A wire, when bent in the form of a square, encloses an area of 121 square centimeter. If the wire was bent in the form of a circle, then find the area enclosed by the circle. So here given the area of the square formed by the wire equals to 121 square centimeter. Both square and the circle formed by the same wire. That means perimeter of the square equals to perimeter of the circle. We know area of a square with side A equals to A square. So here A square equals to 121, or A equals to square root of 121, which is 11 centimeter. Now perimeter of the square with side A is 4A. So what is the perimeter of the square, which is nothing 4A equals to 4 into 11, which is 44 centimeter. As per the given question, 2 pi r equals to 4a. That means 2 pi r equals to 44, or r equals to 44 by 2 pi, which is 44 into 7 by 22 into 2, which is 7 centimeter. Now area of the circle with radius r is given by pi r square. So the area of the circle is 22 by 7 into 7 into 7, which is 154 centimeter square. Hence the area enclosed by the circle is 154 centimeter square. The answer. The cost of fencing a circular field at a rate rupees 36 per meter is 11,880. The field is to be plowed at a rate rupees 0.60 per meter square. Find the cost of plowing the field. Let small r is the radius of the given field. Now the length of the fence of the circular field equals to total cost of fencing by rate. That means we can say length of the fence of the circular field is 11,880 by 36, which is 330 meter. That means circumference of the field is 330 meter. But what is circumference? It is 2 pi r equals to 330 meter, or r equals to 330 by 2 pi, which is nothing but 330 by 330 into 7 by 2 into 22, which is 52.5 meter. Now area of the field is pi r square. So here area of the field is 22 by 7 into 52.5 into 52.5, which is nothing but 8,662.5 meter square. Now given that the cost of plowing 1 meter square field is rupees 0.60, so total cost of plowing is area of the field into cost of plowing, which is nothing but 8,662.50 into 0.60, which is rupees 5,197.50. Thus, the total cost of plowing the field is rupees 5,197.50 is the answer. Circular footpath of width 2 meter is constructed at a rate rupees 20 per meter square around a circular park of radius 1500 meter. Find the total cost of construction of the footpath. Take pi equals to 3.14. That means in this question we have to use pi equals to 3.14, not 22/7. Let radius of the park, that means inner radius of the park, small r, equals to 1500 meter. Now width of the footpath around the park is 2 meter. Let capital R is the radius of the park including footpath. That means we can say capital R equals to 1500 plus 2, which is 1502 meter. Now area of the footpath is pi capital R square minus pi small r square, or it is nothing but pi taking common capital R square minus small r square, or you can write it as 3.14 whole into 1502 whole square minus 1500 square, or it is equals to 18,852.56 meters square. Now total cost of construction of the footpath at the rate rupees 20 per meter square is 20 into 18,852.56, or it is nothing but 3,77,051.2. Hence, the total cost of construction of the footpath around the park is rupees 3,77,551.20. Is the answer. The short and long hands of a clock are 8 cm and 12 cm long respectively. Find the sum of the distance traveled by their tips in 2 days. Given that the short and the long hands of the clock are 8 cm and 12 cm long respectively, now distance traveled by the hands of the clock equals to number of revolutions made by the hands of the clock. Now in one day, the short hand means the hour hand of the clock makes 2 revolutions, and the long hand, or we can say the minute hand, makes 24 revolutions. So we know that in one revolution, distance traveled by the hands of a clock equals to circumference of the circle, which is nothing but 2 pi r when we take r small r to be the radius of the circle. So in one revolution, the distance traveled by the short hand of the clock is 2 into 22/7 into 8, or it is nothing but 50.28 centimeter. And the distance traveled by the long hand or the minute hand is 2 into 22/7 into 12, which is nothing but 75.42 centimeter. So in one day, the total distance covered by the hands of the clock is 2 into 50.28 plus 24 into 75.42. Why so? Because 50.28 is the distance covered by the hour hand or the short hand, and in one day it makes only 2 revolutions. In one day, the short hand makes only 2 revolutions, so it is 2 into 50.28. And the long hand, or the minute hand, it makes 24 revolutions. Therefore, it is 24 into 75.42. Or the total distance is 1910 or 1910.64 centimeter. So the total distance covered in 2 days is 2 into 1910.64, which is nothing but 3821.28 centimeter. Thus, the total distance covered with the hands of the clock in 2 days is 3821 meter, 21.28 centimeter. Is the answer. The shaded area in the adjacent picture between the circumference of two concentric circles is 346.5 centimeter square. The circumference of the inner circle is 88 centimeter. Find the circumference of the outer circle. Let's draw the picture first. Let small r and capital R be the radius of the inner and outer circle respectively. Given that the area of the circular path is 346.5 centimeter square, that means pi into capital R square minus small r square equals to 346.5. Let this is first equation. And the circumference of the inner circle is 88 centimeter. That means 2 pi r equals to 88, or we can say r equals to 88 by 2 pi, which is nothing but 88 into 7 by 2 into 22, which is 14 centimeter. Now putting the value of small r in equation 1, we get pi into capital R square minus 14 square equals to 346.5, or it is nothing but R square minus 14 square equals to 346.5 by pi, or on expansion it is R square minus 196 is 7 by 22 into 346.5, which is 110.25, or R square equals to 110.25 plus 196, which is 306.25. So R equals to square root of 306.25, which is 17.5. So we got the outer radius of the circle. So circumference of the outer circle equals to 2 pi r. So circumference is 2 into 22 by 7 into 17.5 into 17.5, which is 1925. Hence, the circumference of the outer circle is 1925 centimeter. Is the answer. Friends, here we saw few questions, few examples. Practice more and more such questions, and in case you come across some difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your questions. We'll discuss some more questions regarding the subject. This one for today's class. Thank you.